Let's start the first category example where ds is having distinct roots. So a question is given: find the inverse Laplace transform of xs is equal to 2s plus 4 divided by s square plus 4s plus 3. So here it is mentioned that ds has distinct roots, so we have to verify that. So suppose in this fraction denominator is s square plus 4s plus 3, so we can say that ds is equal to this. Okay, so now if we try to break this signal s square plus 4s plus 3 like this, s square plus 3s plus s, so 4s is breaked into this 3s plus s and then plus 3. Then if you take common s, then s plus 3, and next if you take common 1, then you can write it as s plus 3. So if you take s plus 3 common from both this, and then you will write s plus 1 here. So s plus 3 into s plus 1, so this is a multiplication of two value s plus 3 and s plus 1. So if you put ds is equal to this and this equal to 0, you will get two values for s is equal to minus 3 and s is equal to minus 1. If you make this equal to 0, then you will get s plus 3 equal to 0 and s plus 1 equal to 0. From there you get two real values of s, that is minus 3 and minus 1. So that we can say that ds has distinct roots. So in that type we need to make this excess function in a partial factors. We have to divide it. Then partial fraction factor, how we can divide, you see here we have substituted this s square plus 4s plus 3 as s plus 3 and s plus 1. Here we have replaced, and the numerator is same, we have written 2s plus 4. In the next line we want to reduce this load in the denominator. Suppose there are two factors here, s plus 3 and s plus 1. We want to cancel out one of the factors so that we can make it a simple fraction in terms of 1 by s plus a. It looks like 1 by s plus a, that we want to achieve from this factor. First we have to modify this given signal or given function into that pattern. So that is why we are writing this 2s plus 4 as this s plus 3 and s plus 1. If you add this, you will get 2s plus 4. So we have to make this like this because we want to cancel out s plus 3 and s plus 1, and so that we can reduce the function. So here see we have written excess like this, s plus 3 by this and s plus 1 by this. So we have to make this function as a sum of two partial fractions. So here s plus 3 and s plus 3 will be cancelled out, and s plus 1 and s plus 1 will be cancelled out. So we will get xs is equal to 1 by s plus 1 and 1 by s plus 3. Okay. So we have a basic formula for Laplace transform, that e to the power minus at ut is equal to 1 by s plus a. So we know that Laplace transform of ut, unit step signal, is 1 by s, and when it at time domain multiply, when we have done this frequency domain shifting by s plus a, then we have to multiply the time domain by e to the power minus at. So that is what the formula is. So if we find the inverse Laplace transform of this 1 by s plus a, so we can write like L inverse 1 by s plus a is equal to this. Okay, so this is Laplace transform output and this is inverse Laplace transform output. So if you see here, when we are getting this xs is equal to these two fractions, 1 by s plus 1 and 1 by s plus 3, so we can take the inverse Laplace transform both sides, and if we take inverse Laplace transform by xs, we will get xt, and then here L inverse 1 by s plus 1 and L inverse 1 by s plus 3. So their inverse transform, you can take the help of this formula where a is this constant. So here a is equal to 1 and here a is equal to 3. So if you put the value of a here, you will get corresponding output here. If you put a is equal to 1, then e to the power minus tut. If you put a is equal to 3, you will get e to the power minus 3 tut. So if you can take this ut common, you can write e to the power minus t plus e to the power minus 3t, then multiplied with ut. So this is the inverse Laplace transform of the given function x is equal to 2s plus 4 by this. So due to the presence of denominator with distinct root, then we can convert this function into partial fractions, um, the two factors, and then using the property of this inverse Laplace transform of 1 by s plus a, we can substitute the inverse Laplace transform here. We can substitute the inverse Laplace transform of 1 by s plus 1 and 1 by s plus 3 in terms of e to the power minus a t ut, where a are the constant, with that is the shift of s plus 3 and s plus 1. So ultimately we are getting the output in time domain as x is equal to this one. So this is the inverse Laplace transform result of the given function x is equal to this one.